So hello dear students, welcome to the lecture 1 of the course. And as I had promised to you all guys, whenever we will learn any new topic in mathematics, especially in the engineering mathematics, so first of all we will see the application part of that particular topic. Okay, now since we are dealing with logarithm, so we will see the application part of log. Okay, so without wasting any further time, we will straight away jump to the point. Okay, so I will consider one example. Okay, and after completing that particular example or after completing this particular video, you would be in that particular stage to understand or to know what is the significance of log. Okay na? So yes, so the example is Richter scale. RITCHER, Richter scale. Student, have you ever heard the word Richter scale? So if you know this particular word, that is also fine, and even if you don't know this particular term or this particular word, that is also absolutely fine. We'll first understand what exactly this Richter scale is. So it is an instrument, it is an instrument used to detect and measure the intensity of earthquake. Okay, so this is the basic use of the Richter scale. Okay, I hope you understood this particular part, what is a Richter scale. So now you would ask to me that, okay sir, I understood what exactly the Richter scale is, but still I had not understood the significance part of logarithm over here. Okay, you need not to worry, we'll see. First of all, you will understand the Richter scale concept. Okay, and while understanding this particular part, we will understand the significance of logarithm. Okay, how exactly it is used in detecting the earthquake. Okay, so as you all know, in graph we have x-axis and y-axis, x and y. Okay, so this particular x-axis represents uh, Richter value, but for our better understanding, what we'll consider this particular x-axis as distance. We'll come to it what exactly it is, and on y-axis we are plotting magnitude. Okay, so now you will scratch your head, and then you will try to imagine that what exactly these two terms are. Okay, so let's suppose this is your earthquake originating somewhere from over here. Okay, somewhere over here, and let's suppose this is your Richter scale, this particular instrument which is used to detect the earthquake. Okay, this is your Richter scale, it is somewhere over here. Okay, so distance between both of them, see this particular distance from here to up till over here, somewhere over here. So this particular distance we are plotting on the x-axis. Okay, and the intensity, just a second, I will take little different color. Yeah, and the intensity of the earthquake, intensity or the magnitude, we are plotting it on the y-axis. So what I will do is I will represent this particular just a second, with the help of different color. Yeah, intensity I will represent with y, and distance we are going to represent on the x-axis. Okay, and thus the plot is being plotted. Okay, so now you will say, okay, I also understood this particular thing, but still I am not understanding that what is the significance of log over here. You need not to worry, we had just understood the Richter scale and the plot of Richter scale. Okay, so like when I was kid, I think just 10 to 12 years back, like my age was around 7-8 years. Okay, and at that time an unfortunate case happened in US and in Japan. Okay, I think in years between, I mean the interval between 2005 to 2011, I don't remember the exact year. Okay, and at that time there were two numbers which were continuously flashing on the news channel, that is 7, and another was 9. Okay, just a second. Yeah, another was 9. So like I scratched my head and I just asked to my father that what are these two numbers. So he said he also don't know. Okay, then I searched on Google at that time. So at that time I didn't understood anything, but yes, I came to know that this is the magnitude. 7 is the magnitude of the earthquake which was happened in USA. So let's suppose over here. So this is your 7. Wait, what I will do, I'll write over here only. 7 is the magnitude of the earthquake happened in USA. Magnitude of earthquake which was detected in USA, and this particular earthquake, it was detected in Japan. Okay, so now again you will get confused that okay, I also understood this particular part, but what is the significance of log over here? Okay, what if I tell to you that this particular 7, it is nothing but this 10 raised to 7? Yes, what if I tell you that the value of 7 is 10 raised to 7, and here the value of 9, it is 10 raised to 9? Sir, how come you write these two particular terms and you can equate it like 7 you are equating it with 7 you are equating it with 10 raised to 7, and 9 you are equating it with 10 raised to 9? I know it is absolutely wrong. Okay, I know it is absolutely wrong, but what I want to tell you is this: 10 raised to 7, that means the magnitude is 1 and then 7 zeros, that means 10 lakh. 10 lakh. Okay, and here the magnitude is 1 and 9 zeros, that means roughly around 1 arab, if I'm not mistaken. 1 arab. Such a huge magnitude it was. That means what, sir? I still don't understood this particular part. First of all, we'll see some of the things, and then we will straight away come over here. That means let's suppose this is your steel land. Okay, oh sorry, just a second. Yeah, let's suppose this is your steel land. Okay, and as soon as this particular land experiences an earthquake, okay, so let's suppose from here the earthquake is originated, and as soon as this particular land is experiencing the earthquake, so the shape of the land, okay, it gets changes. Okay, something like this. Just a second. The shape of the, just a second, what I will do is, yes, oh sorry, I will take a different color. Yes, something like this. The shape of the land changes, and at the end it would be something like this. See, yes, that means what, this land is experiencing the earthquake and it is changing its shape, and basically what it is experiencing, it is experiencing a shake, or it is shaking, the land is shaking. And by what factor it is shaking? It is shaking by this factor, 10 raised to 7. In case of USA I'm talking, and in Japan it was experiencing the magnitude of 10 raised to 9, but that means what, it was shaking by factor of 10 raised to 9. Okay, that means if let's suppose if the magnitude over here is 1, so here it is 1 into 10 raised to 7 in case of USA, and in case of Japan it is 1 into 10 raised to 9. Oh, such a huge number it is. Now you will tell that okay sir, I also understood this particular thing. So now we will come over here to this particular plot. Now you just imagine, let's suppose somewhere like each and every day, somewhere around, I just had a research. So each and every day there the earth experiences the earthquake of magnitude 2, at sometimes 3, at sometimes 4, which is not that much severe, but when it exceeds magnitude of 5, here it becomes severe. Okay, here it becomes severe. Okay, so from 5, 6, 7, 8, 9, this particular magnitude they are considered as severe. Okay, this particular magnitude they are considered as severe. But now you just think that okay, so if I consider 2, that means they are talking about 10 raised to 2. As we saw over here in USA, the earthquake which was detected, it was 7, that means 10 raised to 7. Okay, it was in 10 raised to 7, and in Japan it was 9, that means 10 raised to 9. Okay, I know that you would get confused that how I had equated this particular two, two things. It is absolutely wrong, but we will come to this particular point after some time. Just a second, let me explain this particular part. So that means, let's suppose at certain distance we are experiencing a magnitude of sorry an earthquake of magnitude 2. That means we are talking about 10 raised to 2. So rather than writing 2, what I will do is I will write 10 raised to 2. Just a second. Rather than writing 2, what I will do is I will write 10 raised to 2. Okay, fine. After some time at certain distance, okay, this particular let's suppose there are different Richter scale at different distances. Okay, after some time the second Richter scale, maybe it experience an earthquake which is of magnitude 10 raised to 5. So now you only tell me, here we are dealing with hundreds, 1 and double zeros, and suddenly here we are dealing with 1 lakh, 1 2 3 4 5. Okay, so how can you accommodate such a huge number on y-axis? See, ideally it is possible to represent this huge number on a piece, sorry, on y-axis, but practically, if you are considering a piece of paper, practically you can't represent 100 and 1 lakh at the same time on this particular y-axis. Ideally it is possible, but practically it is not possible to represent a huge number. So this was the main drawback. See, what I am writing over here is, just a second, I will take this particular color. Yes, practically it was not possible, to represent what, to represent huge number on y-axis, as of now it is on y-axis. Okay, so that was the drawback, and this is what, and this is the drawback which we were facing, drawback or the consequence which we are facing, drawback. So to overcome this issue, logarithm was invented, or basically logarithm played an important role in this particular Richter scale. So how come the logarithm played an important role? So we'll come over here. So actually in log there is one formula, or there is one rule. I know that I had not teach you any rule, but as of now you just try to think in this way. See, if you have any number, let's suppose 10 raised to x. Okay, so in log we write it as log of 10 raised to x to the base 10. Okay, so this is one rule. I know you don't know anything about log, but it's absolutely fine. You just see this particular thing. Okay, we are going to see this particular rule, or we are going to learn this particular rule in the upcoming videos. As of now you just stick to the basic, okay, and just try to see what I am going to do, and then it is written as x log 10 to the base 10, and the value of this particular thing, that means log of 10 to the base 10, it is 1. So at the end we are getting this particular thing as x. Oh, that's really nice thing. That means what? That means, see, the earthquake which was detected in USA, it was 7. Okay, sorry, yeah, in magnitude it was 7, but in reality it was 10 raised to 7. Okay, it was 10 raised to 7. So what I will do is, again I will write over here 10 raised to 7. So how can I write 10 raised to 7? So for that I will I will introduce log in it. So log to the base 10, 10 raised to 7. Oh, that means what? That means this 7 will come over here, and then log to the base 10 and 10. And as I said to you, the value of this particular thing is 1, so we end up getting 7. Oh, that's really nice. That means what? That means in Japan the earthquake detected was 10 raised to 9. So rather than writing such a huge number, we will end up writing as 9. Okay, obviously with the help of log. Now you will say that, okay sir, I understood this particular part, but what is the main significance of log? My dear student, the main significance of log is this. Just a second, what I will do, I will draw this particular graph over here once again. Just a second. Oh, sorry. Now I won't represent the x and y axis, I mean the distance and the magnitude. Okay, I'm not going to write that, but what I want to say is this. Just a second, I will just increase the thickness of the line. Yes, so let's suppose this is that particular graph. Okay, so see, just 2-3 minutes back we were not able to represent such huge number. This were very huge number. It 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 was very huge number. Just 3 minutes back we were not able to represent such huge number, but by converting this huge number into a smaller one, see, 10 raised to 7 we converted it into 7, and 10 raised to 9 we converted it into 9. That means these were, see, these were very huge number. I am writing in short form huge number hn, and this 9 and 7, these are what, these are very smaller number as compared to 10 raised to 7 and 10 raised to 9. 9 and 7 are very smaller number. Oh, now I got the point, sir. That means what? Rather than writing 10 raised to 7 and 10 raised to 9, I will write directly as 7. Okay, and then I will write over here as 9. Okay, and now we can easily represent these two numbers on y-axis. Okay, because yes, this kind of number can easily accommodated on the piece of paper, but when we are dealing with 10 raised to 7 and 10 raised to 9, it was not at all possible for us to accommodate such a huge number on a piece of paper. So here the log played a very significant role. Okay, so to give you a brief idea about what exactly the log did, or basically, long story short, what exactly the log did. Log, basically logarithm, by using logarithm, just a second, yeah, by using logarithm or log, we can convert very huge number into a smaller ones, into a smaller number or smaller ones. That's absolutely fine, smaller one. Okay, so this was the main conclusion. Okay, or this was the main conclusion of this particular video, and this was the main application of this particular video. Okay, and another thing what I would like to tell is, see, this, the earthquake detected in USA was 10 raised to 7, and that in Japan was 10 raised to 9. That means the difference between both of them, or what I can say, the earthquake which happened, unfortunately, which happened in USA, sorry, which the earthquake which happened in Japan, it was almost 100 times stronger than USA. Oh, and that's why, if we see 10 raised to 7 into 10 raised to 2, so we end up getting as 10 raised to 9. Okay, and that's why if you could see, if we apply log over here, so we get 7, and if we apply log over here, we get 2, and the difference between both, sorry, extremely sorry, we get 9, and the difference between both of them, it is 2. This 2 represents that the factor is 100. Okay, so I really hope that you understood this particular part, this particular concept of logarithm, that why we are using logarithm. Okay, again I'm revising the concept. First of all, when we started the video, we just saw about the Richter scale. So basically, the Richter scale is an instrument used to detect and measure the intensity of earthquake. Okay, then what we saw is this particular graph, and the graph was between the distance, okay, and the magnitude. So we saw that, let's suppose this was your earthquake, okay, and this is your Richter scale placed somewhere over here. So the distance between both of them, it was plotted on the x-axis, and the intensity of the earthquake, it was plotted on the y-axis. Okay, and then we saw that on the y-axis we were getting very huge number. That means 10 raised to 5, 10 raised to 7, which I told to you over here. Okay, due to earthquake, the land was shaking by a very high factor, very huge factor, that is 10 raised to 7, 10 raised to 9 in our case, that means in US and Japan. So it was not possible practically to represent such a huge number. Okay, this kind of earthquake also happened, that means 2, 3, 4, that means 10 raised to 2 to 10 raised to 4, but that is not that much severe. okay, but magnitude after 5 or 5, okay, earthquake of magnitude 5 or more than that, it is considered to be very much severe and disastrous, okay, which unfortunately happened in Japan and USA. So what we saw, it was not possible practically to represent 1 lakh, 10 lakh and 1 arab on the y-axis. So to overcome this issue, we make use of log, okay, and we learn one rule. Although we are going to learn this particular rule in the upcoming videos as well. For your better understanding, I had just shown you this particular rule, okay, so that this particular thing would be crystal clear to you, okay. So you need not to worry that, sir, I really don't know this rule. You need not to worry, we are going to see this particular rule in the upcoming video, okay. So yeah, this was the rule. If you have number raised to x, okay, let's suppose 10 raised to x, so log of 10 raised to x to the base 10, so this particular value, see this x comes over here, that means over here, and this particular thing remains as it is, and log 10 to the base 10, the value of this particular thing, it is 1, okay, and then this x remains as it is, that means we are multiplying it with 1, okay, anyhow, so that means x only, okay. So what we did similar thing over here, 10 raised to 7, so here the x was 7, so we applied log to the base 10, and then this 7 came over here, oh sorry, just a second, yeah, this 7 came over here, okay, and the value of this particular thing, that is log to the base 10, 10 is 1, so that's why we end up getting value as 7. Similarly, the case which happened in Japan, the earthquake which happened in Japan, it was 10 raised to 9, so rather than writing 10 raised to 9, we wrote it as 9, okay, obviously by using log. And now what I wanted to say, or what we concluded in this particular video, just 3-4 minutes back we were unable to represent 1 lakh, 10 lakh and 1 arab on the y-axis. So rather than writing, or rather than just representing such huge number on y-axis, we made use of log, and then we converted this particular huge number into a shorter values or a smaller values, that is 7 and 9. So let me write over here as well, this is representing 10 raised to 7, okay, and this is representing 10 raised to 9, 10 raised to 9, okay. So this, rather than representing such huge number, we just made use of log, and we are representing 7 and 9, okay, on this particular graph. So this was the conclusion. By using logarithm, we can convert a very huge number into smaller one, okay. So now I hope your concept would be crystal clear, that why we are using log in the real world scenario. And this is why students really like to learn from me, because first of all I clear the application part, and then we will study the then we go on the clearing the concept about that particular topic, okay. So I really hope, I really hope that you understood each and everything, especially the application part of log. And even if you face any difficulty, or if you have any doubts, feel free to ask me at any time, okay. So I am ending this video over here. Thank you for listening me patiently. Thank you.